Ready? So today is the second week of homecoming week. It's almost over. Jesus help me. September, what is today's date? The 24th. Thank you. 24th. Wednesday, today and Wednesday, we're going to go over these ideas of bonding and what is a molecule, what's a covalent molecule, what are biomolecules, how are they made. We talked about elements. Let me pull up a periodic table real quick and put it up at the top so that we have it as a reference. You're going to be building some biomolecules in class. Using some model kits that Mr. Dugan has so kindly let us borrow. It's from his collection. They're very expensive, so we're going to take very good care of them. If there's literally one piece missing, it's going to be my butt. So we're going to make sure that that doesn't happen. So when we're looking at the periodic table, as I told you last time we talked about the elements, it's these first four rows, or two, really it's the first two rows, but we'll go ahead and say it's the first. It's mainly for, what the heck with this thing, it does it. Okay, so, one of the things I hate about Pep Rally Week and Homecoming Week is you guys, all you do is you're so sidetracked by this stuff, by this social that it takes 5 or 10 minutes to get you focused on class again. Could you get those stools down, please? Take the headphones off. Put away. Get the note binders open, please. Thank you. Thank you for the rest of you to having your binders open. I appreciate it. It's not that I hate all the social stuff. I think it's cute and fun, but you have to know how to refocus. All right. So first three rows really. Again, I circled we talked about specific elements, C, H, N, O, P, and S. The elements of life, incredibly important. That's carbon. That's hydrogen, which is over here on the left side. That is nitrogen. That's oxygen. That's phosphorus and sulfur. You'll notice that most of the elements involved are right here. They're these red elements. They're nonmetals. They're very important. This hydrogen is incredibly important. You'll see why in a minute. And carbon is arguably the most important one. All right. So. Huh?
What's the third letter?
That's it. You should already have it in your notes, but I'll do it again. This is carbon,
Oh, I do.
hydrogen. It's worth going over again. Nitrogen, oxygen, phosphorus, and sulfur. Those are the 6 big letters, 6 big elements. There are other elements, obviously sodium, potassium, magnesium, the vitamins that you take during the day, those kinds of things are all very important. But these are what the biomolecules that you're used to are mostly made of. So let's talk about, we talked about bonding. We said carbon can make 4 bonds. Right? Is that correct? All right. Always makes 4 bonds. It's going to be the way that you're going to be able to figure out what is going on in any one of these drawings that you draw. When you work with these models, the carbon will only have 4 connecting points because each carbon can only make 4 bonds. Each connecting point is going to be representing a bond. A bond is a shared electron. These are shared electrons. Two electrons are shared. So you know how 2 points equal a what? 2 points equal a what? From algebra, from math, 2 points. 2 points on a graph, define a line. 2 points on a graph, define a line. So when you see a line, on one of these drawings, it is a sharing of 2 electrons. They don't draw the dots, they just draw the line. So this line is 2 electrons being shared. Is that understood? Mm-hmm. Okay. In order to get, do you remember what the 2 rules of bonding were we talked about? Seeing blank faces, let's go ahead. I know lots happened. We've done a lot of stuff. But the 2 rules of bonding are that atoms tend toward being neutral. Atoms want to be neutral. I don't like using the word want because they don't have a will, but they tend to be neutral. Atoms tend towards neutrality. That's what they need to be. The other rule that's going to drive this bonding is that atoms tend toward having a full octet. Octet means 8 electrons in their valence shell. The word octet means 8 electrons in the outer shell. For most atoms. Sometimes it'll be just 2. Yeah.
What's the 8 supposed to represent?
What's that?
The 8 in the parentheses?
8. Octet means 8.
Oh, okay.
And so it's 8 electrons in the outer. That octet means 8 electrons in the outer shell, because most atoms are going to end up with 8 electrons in the outer shell. We're going to do some practice drawings, and then we'll make some models. So we're going to start with some very basic ideas here. Just remind me, we did cover this? We did talk about it, at least mention it? Yes? No? The octet rule? The bonding rules? No? Okay. So we're good with these 2 rules? We're going to apply them now. Do you understand what I'm saying? You may not have a clear understanding, a vision of what those things are, but we're about to draw some of them. Let's start with drawing the simplest atom on the periodic table. And that's the atom hydrogen. Hydrogen has, if we look at hydrogen has, I covered it up, but its atomic number is 1, and its atomic mass is 1.0 something. Oops. Its atomic number is 1, and its atomic mass is atomic number equals 1, and its atomic mass and it's an average atomic mass equals 1.0 something something. All right. So I think it's 109 or something like that. It rounds up to 1. Now, do you know what atomic mass, atomic number is? You probably covered it in middle school. No one's, some people have, and others? Yes? Raise. Atomic mass? What is atomic mass? That's cool. I mean, I just want to know what you know about it, so I know how to phrase my explanation. I'm going to explain it anyway. So, does anybody have any other ideas? It's a box and a periodic table. That's good. And there's another box that tells you the number. So there's 2 boxes on the periodic table. One tells you atomic number. The other one tells you atomic mass. All right. So it turns out that atomic mass, it turns out when you have an atom, first of all, an atom is very tiny. When we talk about atoms, they are, I'm giving you definitions, so you want to make sure you write them down, and you want to make sure you put them in, and I'll highlight the most important stuff when we're done. Atoms are the smallest biologically relevant, at least at the high school level. No, that's not really true either. How do I describe this? I used to say it's the smallest particle of matter, right? But that's not true, because we're actually going to talk about the smaller parts that make it up. But let's just say the smallest component of matter. That retains its property. So an element is a type of atom. All right. So when you talk about an element like gold, Au, that's the symbol for gold. Gold has a specific number. Its atoms are made of a specific atomic number and a specific atomic mass. That's what makes it gold. We'll talk about, we're going to use hydrogen as an example because it's much easier to draw and work with. We're going to use the elements of life. We're not going to worry about the bigger ones, but we'll look at oxygen and carbon and hydrogen because they're really important for life. But gold is something everybody's used to, so gold is one of those things you can break. Gold has an atom that's made of a specific, is made of atoms that have specific atomic number and a specific atomic mass. Does that make sense? What's the difference between gold and silver? Its atomic number and its atomic mass. What's the difference between silver and oxygen? Its atomic number and its atomic mass. So all the elements, their differences are really, it actually turns out to be, their differences are all about this really important number. That's probably the most important number on the periodic table, though the mass is important as well, is this one, the atomic number. That's an excellent question. No 2 elements on the periodic table have the same atomic number. If they have the same atomic number, then they are the same element. That's what makes it that element. Then if you have a different atomic mass, then we call it an isotope. You've heard of the word isotope? Yeah. I'm sure you guys covered it in middle school to some extent. They probably just glossed over it really quickly and didn't really think much of it, but they become important. So this is an atom, and it's made of, atoms are made of 3 things. And I could describe the experiment to you, but I don't really want to do that because there's It gets into detail, and I love to do it. It's a great experiment. It was one of the best experiments I've ever even heard of. But they took, just to make it short, a short story, they took X-rays and they shot it through a thin gold foil. Shot X-rays through a thin gold foil. And their objective was to figure out what was the atom made of and how were the components put together. You know what? I'm going to go ahead and do the experiments in general. I'm not going to go into details. So they had this atom, and they want to know what was it made of. And one of the things they used to be able to do is take electrons. That's one of the subatomic particles. One of the particles that's smaller than an atom is an electron. You've heard of electrons? Yeah. Then what do they make? What do a bunch of them make? Put a bunch of them together, shoot them down somewhere. What do we call that? They are particles streaming through the air or streaming through something. What do we call it? Electricity. And that's what electricity is electrons flowing. So electrons are negative, and they're very small. They're so small that their mass is negligible. Okay? That means you can ignore it. So if I get on a balance or a scale and I weigh 270 pounds and I take this piece of paper and I put it on it, is that going to show up on the scale? No, because it's just negligible. It has mass. If I use a scale by itself, I can measure it. It takes up space. It is matter, but it doesn't. It's nothing compared to me. So when you look at an atom, an electron is mass. Even though it's a very important component of an atom, its mass is very small. So what's a summary of these ideas? 1, mass is small. But the electron is important. So do we got that? That would be a take home. The mass is small, but the electron's important. Up here I would write atomic number defines the element. Isn't that what we said? And that was from a question from one of your fellow students. And then atomic mass, we could say any element can be made of atoms with the same mass, the same atomic number, but different mass. And we call that an isotope. So these are two ideas that are implied by what we talked about over here on the right. So these are kind of three big ideas that we kind of took away from all this, right? Are we good with this? On the big ideas? I mean, is that good here? I'll wait till everybody's done copying. So that's how Cornell Notes helps you. The things on the right, I did for you. But what would be ideal, what would make it so much more valuable to you, is if you guys went into a study group or read the book or found something online or thought about it during lunch or came during tutoring and said, man, do you mean that the atomic number defines the element? Which is something you did in class. You did that in class, didn't you? You questioned that in class. And because you questioned that in class, we came to this big conclusion. I didn't state this, right? I didn't make this statement. This was you asking a question right? Whose answer turned out to be very important. Important enough that we had a number at number one in our three big ideas. That came from a question, did not come from a statement that I made. Then this one came out of a conversation that we had. And the last one was a statement I made because of the follow-up to that question. So having a conversation about this, asking a question in class is very, very, very valuable. But having this conversation with a group of your fellow students and coming up with wrong answers and making arguments to each other really, really makes this stuff a deep learning event. All right. So electrons are very small, but mass is negligible. All right. So let's look at the simplest atom. Hydrogen, which we said had atomic number of 1. So what does atomic number mean? Like, that's the next big question, right? Did anybody have that question? What is an atomic number? We said it defines the element, but we didn't say what it was. Does anybody know what atomic number is?
It's ain't it's like that big number that's on one.
Yeah, that's right. It's the big number that's on the periodic table. You're right on that. That's correct. So no one knows. That's fine. So there's 3 components in an atom. Well, there's more, but there's three components that we're going to be worrying about. That's to everything that you know. Everything that we know that we can touch, everything we can smell, everything that we breathe in and breathe out, all of it has 3 components. They're made of atoms, and they have 3 components. The 3 components are protons, are electrons, and then there's neutrons. And usually we put an N. Neutrons have a 0 charge. 0 charge. Electrons have a -1 charge. And protons have a +1 charge. So for me, protons is easy because I think protons positive, right?
Yeah, when I did this during the summer, they made me like divide like protons from electrons or neutrons from electrons. Like to get
Add and subtract. You probably add and subtract these protons and electrons, and you probably made some calculations of protons and neutrons. But when we take a look at electrons, they have a negative charge. Now we can't see these things, and so the way they figured this out is they had this thing called a cathode ray tube. That a tube full of in a vacuum full of a gas that if electricity was being conducted, it glowed, and they had a negative end on this side and a positive end on this side. What do positives and negatives do? What do positives and negatives do? You know this. Come on. Oh, Frank, thank you. I'm like, who's the Frank? Do you have a phone? Here. Where'd they find this? I do not know. Oh, I don't know. So positive, negative, and positive. You don't know what do they do to each other? Negatives and positives, what do they do to each other?
Neutralize each other?
Okay, that's a good idea. Yes, keep that in mind. That's important. But what do they do? What do magnets do? What do opposite sides of a magnet do? They attract. That's right. So they attract each other. So electrons can move, the protons can't. So the electrons start moving towards the protons. And if there's a lot of them, and there's a beam of electrons. It's a ray, almost like a ray. I'm drawing a bunch of little particles, somebody called them particles, move in an array. We know this side, we just called this side negative arbitrarily and this side positive. So we want to know whether electrons were positive or negative. We know these were electrons, but we didn't know what kind of charge they had. Were they like this positive or were they like this negative? We didn't know. So they took something that was negative. They took an object, and I'm just making a very simple description of the experiment. And they took this negative block, and they put it near the beam. And what did it do? What happened? What happened to this beam of electrons? Did it move toward the block or away from the block? Did it move toward the block or away from the block? Away from the block. Does that make sense? Because we knew we would not have known had you and I not already known that their electrons are negative, but they realized that the negative. So then, what happened when they did the same experiment and they did the same experiment, except this time it was a positive charge? What do you think happened to the beam of electrons? What happened to the beam of electrons when the block was positive? And it was deflected away from or towards the block? Towards the block. You know what this is. This device that you see in front of you. This thing called a cathode ray tube. Do you know what this is? You call it a television. You never wonder how you get pictures on a television? You never ask that question? How do you get pictures on a television? You just never, it's just a magic box. It works. It's a little spirit in there that changes, is acting for you. You never wondered how your cell phone has pictures on it? That just, you just turn it on and it works. That's all you care about. Okay. All right, well, it all started with cathode ray tubes. Cathode ray tubes allowed us to shoot electrons in a beam, and magnets could move the beams around, and then you had paint that would glow, absorb the electrons and glow with no, it's not a pigment, but little devices that glow turned on with depending on where the electrons were hitting, and they had little pixels, little blocks that would turn on and off. That's how you get a picture. You paint a picture on a screen in incredibly fast speeds with these electrons. That's how you get a screen showing you a picture. In any case, that was how we figured out that electrons were negative. And so we knew then protons were positive, and various other experiments showed us that protons had a lot of mass. So we had protons had mass, they were big. Electrons were small. Electrons were small and were negative. And then there were neutrons. We knew that they were neutral. We knew that neutrons were neutral. They were as big as a proton. Did you hear me? They were as big as a proton. These had the same mass. What's the difference between these two, proton and neutron? That's right. One's positive, one's neutral. But they have the same mass. So what we call this mass is atomic call this mass atomic mass unit. Atomic mass unit, AMU. We said an AMU, or an atomic mass unit, is equal to 1 proton. And since neutrons are the same, they're also the same atomic mass unit. So the mass of an atom, of a proton, is 1 atomic mass unit, 1 AMU. Does that make sense to everybody? Yes or no? An electron has a tiny, tiny fraction of that, the most negligible. So really, when it comes to the mass of the atom, what's going to determine the mass of the atom? If we're measuring the mass of the atom by, come on guys, help me out here. If we're measuring the mass of the atom by how many by mainly protons and neutrons, what's going to determine the mass of the atom? I'll say it again. If we're measuring the mass of the atom is mostly protons and neutrons. What's going to determine the mass of the atom? The number of protons and neutrons. How many protons and neutrons you have. Every proton is worth how many? 1 AMUs. Every neutron is worth? No, neutron is worth 1 AMU. The charge on the neutron is 0. All right, the charge, but the mass is 1. Is that making sense to you? You got to get this straight. Confusing it on the test is going to get you the wrong answer. The charge is zap, right? Electricity, that's charge, that's negative. There's also positive, right? The opposite of the negative, of the electron, is positive. Are we clear? Like a magnet, positive side and negative side. We're good? So, you got to get that straight because it's going to get real confusing if you don't. And you're going to be like, is this too much? It's not too much. If you memorize this, the protons and neutrons, where proton is 1 atomic mass, and neutron is 1 atomic mass unit, and neutron is 0, and proton is positive, electron is negative, you'll be fine. You can figure everything else out. Everything else is just adding and subtracting. That's all there is. Simple numbers, small numbers. Not hard. As long as you remember these 3 facts, everything else will flow. Still going to take some work, but it's going to flow. If you don't remember these 3, confuse these 3, you're done. You're going to get it wrong. All right. So let's look at hydrogen. Hydrogen has an atomic mass, hydrogen has a proton number of 1. Atomic number of 1. It has atomic mass, average atomic mass 1.000, I think 9 or something like that. Maybe it's 4. I don't remember. I'm just gonna put 4, and you guys can look it up later if you like. You guys have in your planners, don't you, periodic table? Mm-hmm. What's the atomic mass of hydrogen?
Oh.
Hydrogen's the top left-hand corner.
1.008.
1.008. And so what does that mean? So in those 2 numbers, what they mean to me is that hydrogen has 1 proton. Does it have any neutrons? If it's atomic mass unit, average atomic mass unit is 1. AMU is 1.008. How many neutrons does it have? What is atomic mass? What is atomic mass equal to? I just said it. In this case, it's 1, average of 1, good. But what is it? When I say atomic mass of 1, what do I mean? That means the number of what? Not electrons, because electrons are negligible. Protons and neutrons. If the atomic mass unit is 1, does it have any neutrons? We know it has 1 proton, correct? Yes or no?
Yes.
We know it has 1 proton. Why? Because the atomic number is 1. So we know it has, that's how many protons you have. Right there, it tells you, hey, you have 1 proton. Hydrogen has 1 proton. How do I know? Atomic number is 1. Period. Or period. We get it? Come on, that was funny. No? All right. Oh, man. I laughed. Kind of. So the atomic number is 1. So we know it has 1 proton. And the atomic mass is the number of protons and the number of neutrons. Well, the atomic mass is 1.008. So how many neutrons do I have? 0.008, right? But this is an average number, so it's not possible to cut up a neutron in little parts. So that's not happening. What happens is that in the universe, some hydrogen has only 1 proton. In fact, honestly, most hydrogen has 1 proton, while some hydrogen has very little. In the universe, very little hydrogen has 1 proton, 1 proton and 1 neutron. So some hydrogen has a mass, atomic mass, equal to 2, but most has atomic mass equal to what? To 1. So because you're averaging it, since most has atomic mass of 1, your number is closer to 1. Do you see that? That's all it is. It's an average. So just round it. Round this number. Write that down. You should be writing it down. This stuff is, it's not written on the board, but this is stuff that you should be writing down. Okay, wait. If you ask me to how many neutrons an element has, I have to look on the periodic table, and now so if I'm asked to how many neutrons I have to round the atomic mass off. So that's an important idea, and it's not written down. I'm going to write it down for you, but this is what's being an active listener and asking questions. So you have to round the atomic mass to get a whole number. That's 1. 2, that whole number is protons plus the neutrons. Is that clear to you? Am I making sense? Who said no? I'm glad you said no. Tell me, what is not making sense to you? What part of that doesn't make sense? Please, elaborate. What's confusing? This one looks like she just gave up. Just turn around, lay her head down. She's like, I'm done. What's going on in your head? Can you translate for me? Because I don't think she understands what I'm saying. What's going on? You all came in screaming and dancing. Come on. All right, my point is we got whole number, we got atomic mass, it's on your periodic table. We got 2 minutes left. It's an important idea. Come on. All right, I'm going to pick something out. Pull out your periodic tables and find carbon. Quickly, we only got 2 minutes. Carbon is the letter C. By itself. There's a bunch of C's on there, but C, only C. Huh? So carbon is, what atomic number does carbon have? 12.0. No, atomic number. 6. Atomic number is always a smaller one. Atomic number is always a smaller one. What is the atomic mass? 12.0 what?
1.
So how many protons does carbon have? Quick. Nope. How many protons? What is the atomic mass? The bigger number?
The whole number is protons plus neutrons.
So this is the protons plus neutrons. What's the atomic number? 6, which is the number of protons. So proton 6. What about mass? How many neutrons does it have? That's right. How did you know it was 6?
Because it's
12. 12 protons plus neutrons. Minus 6 protons. Where did I get 6? From the atomic number, from the periodic table. Everything comes from the periodic table. This 6 here is this 6 here, which is the same 6 as here. Atomic number is the number of protons. Atomic mass, why did I just use 12? Why did I use 12.01? Because don't put anything away. Why did I use 12 instead of 12.01? Because we round it. Why do we round it? Because it's an average. Don't put anything away. I don't care. I don't care. Don't, just sit down. Sit down. 12.01, we round it off. Is that clear? So 12 minus 6 equals 6. And now we know how many neutrons we have. Now you can put things away and leave. It's really rude to put things away too quickly. It is not time to leave. I have a timer. I had 2 minutes when the timer went off. I believe if you watched the video, you started putting stuff away before that 2 minutes was up. You can watch the video and listen to it. Element X. We got 2 minutes, so don't anybody move. Element X, it's a variable. It's not an element, so don't go looking for X on a periodic table. Element X, XE is on there, but not X, is an element that has 12. I'm sorry. That's my bad. All right, 12 neutrons and atomic mass of 25.026. What, let me just round it off, so forget this fraction, it's just gonna confuse things. I'm making this up, so it might mess things up. So, what element is it? What element is atomic X? Go. Do you know that song? No? It's old. Oh. No, this is easy. Again, oh, the song, the pet. I get you. Yeah, I'm not good with.
Magnesium.
How did you get magnesium? Listen to what he did, and maybe he got it right, maybe he didn't. Let's go through. I made this up, so I don't know. So what did you do?
Search for it on the periodic table.
Search for what?
The atomic number and the atomic mass.
How did you can't search for atomic mass. Atomic mass, this could be an isotope. It could be, so you can't do that. But atomic mass is what? What is atomic mass equal to, people?
The number of
Protons and neutrons. Is everybody good with that? There's no problem with this so far. What is the atomic mass? The atomic mass is 25. What is 12? Is number of neutrons. If I subtract the two, what do I get? 13, which is what? The number of protons. What element is element 13? Aluminum. So the element is defined by the number of protons. This is the atomic number. Again, definitions come to your rescue. Knowing the definition of those three things, atomic mass, atomic number, will help you solve the problem. If you're given the atomic mass and the neutrons, you can find the atomic number. The atomic number, just find it on a periodic table, and it tells you this is aluminum, Al. All right. That's it for today. Have a good one.